At this moment, we are discussing motion. This is part 2 of the motion lab. Motion control is probably one of the most striking features or advantages of the Logix engine, and it's a combination of the Logix engine and the hardware. In the beginning, when they first came out with their motion products, anyone who had been doing servo motion control was immediately astonished at how quickly and easily you could set up a servo axis with RSLogix 5000 and the motion hardware. And we regularly, and I did myself in class, did the 5-minute challenge where I could from scratch completely configure and tune a servo drive between 5 and 10 minutes. The variation just depends upon whether or not you've got all the information in front of you, because you do need the part numbers so you can immediately acquire the EDS files for these different pieces of hardware. Because remember, when you configure a axis of motion in RSLogix Studio5000, you're creating kind of a virtual axes, because you're taking all of the data structures, methods, connections for a whole servo axis, and you're creating it electronically, meaning that it's a data structure, and then once you connect up the real hardware, it works. So let's get on into our next chunk here. If you just happen to drop in on this video and you didn't watch part 1, I don't know if part 2 will work for you. If you already know how to set up a drive and you just want to use the motion direct commands, this is a good place to jump in. Well, alright folks, it's showtime. This is what every motion guy waits for, is to see things move. Now keep in mind, if you already had your part numbers all lined up and a few details, it has only taken you between 5 and 30 minutes to get to this point. So now we're going to make things move. It's always nice to make things move, especially when they move in a way we expect it. That way we know we have it set up right. So we're going to right click, and by the way, you need to be in the remote program mode. In case I didn't remind you, you don't want to be in the run mode. Go to your axes, because we only have one axis, so we right click and we go to motion direct commands. This is really cool. First time I play with this, considering that I remember doing servos years ago when you had none of this. This was really quite a bit of effort in order to configure the drive, tune it, and then actually make it do things. And this is available to you once the axis is configured and tuned. This is available anytime. In the remote program mode, go to motion direct commands and you can make that axis dance to your tune. Now we come up with a list of instructions, and these are motion instructions. Motion servo on, motion servo off, motion axis shutdown, motion axis shutdown reset, etc., etc. Here's motion moves: a stop, a home, a jog, a move, a gearing, motion axis gear, and so forth. You're looking at quite a few of the instructions, at least the basic ones, and you can execute these from right here. Now at this point, I did point out to you that if you look over at your drive, my network LED is solid, but my module status LED is blinking. Well, green means good, but blinking means, in this case, that it's not enabled. The drive is not enabled. And there is a pop-up window that will pop up down here as we go. Right now we're going to do an MSF, that is motion servo off. Now it's technically already off, but we're going to execute it. So execute, and we're waiting for a completion. Go up to the top, go down to the bottom. We probably should have cleared this, but this was the last thing we did. We downloaded, and then we did a motion direct command to rotary, we did a motion servo off, no error. And of course, that light is still blinking. What I wanted you to see, I want to bring up this error window down here so you can look at this as we go. Always glance at the error panel when it pops up, even if it says no error, just to get accustomed to looking here for the status. This should have resulted in a blinking module status LED on the Ultra drive. Now, I realize that not all of you have an Ultra drive. Somewhere on that drive, there's going to be a module status LED. If you're not sure if the drive is enabled or not, check the state of this LED. Now, this LED, of course, is on the drive, and the drive is behind the door when the cabinet's closed. So when you're doing commissioning or startup, you're going to have to rely more on what you see in front of you here on the screen and less on the LEDs on the front of the drive. But if things aren't working right, you go look at that drive. If it's a Circos Ultra drive, it better say 4 on the display, and the network status better be solid green. The module status itself, if it's blinking, that's not bad, because it just means that the drive is off. Next thing we did was we explained the motion group shutdown button. This is kind of your panic button right here, motion group shutdown. That shuts all of the axes down in that group. The motion group shutdown button is an MGSD command, motion group shutdown. And it's an execute push button all rolled into one motion. So you don't select, that's not the motion axis group shutdown instruction. That is a button that executes this instruction right here and the execute button all in one click. This allows you to shut down the whole group from 1 to 32 axes if you make an error. In other words, if you see something you don't like, you can quick click on this button and it shuts it down. If you use it, then you have to use the reset commands to get the axes reset. We're actually going to do that. I'm going to do it from here though. I'm going to select the motion axis shutdown and click execute. You see it did a motion axis shutdown, no error. Now if you look over at the drive, nothing's changed. The green light's still blinking, so there's no faults or anything. Now, one thing I forgot to mention is the first time you bring up this motion direct commands box, there may not be an axis selected. There wasn't the first time I opened this, but since I've already opened it in the course of tidying up the Word document for the manual as I go through these labs, I selected rotary. Now if I had, remember, if there's more than one axis, you could have another axis. You don't want to accidentally do something with an axis that you're not looking at. So you needed to select the axis, then do the shutdown. What is the state of the drive module status LED? It should be blinking green. Try executing a MSO. That is a motion servo on. So we'll try to execute it. Of course, we get the message that we're expecting. Execution error. The axis is in the shutdown state. You can't turn it on if it's in a shutdown state. So how do we resolve this situation? Let's look down through the instructions and see if we can find one to reset the motion group. We only have one axis, but this command shuts them all down, all 32 axes, if you're maxed out in your motion group. So as we scroll down through there, we see, of course, right underneath of the shutdown, we see the shutdown reset. So that wasn't that difficult. So let's do a reset. Click on that instruction, execute. See, it did a motion axis shutdown reset, no error. Then of course I ask you the question, did that stop the blinking LED? Of course it didn't. It wasn't supposed to. Execute a motion servo on, MSO, execute. Now you probably didn't hear it in the background, but I can tell when the drive's enabled because there's a little bit of sound that comes when I would guess you would say when the bus voltage goes up. And now we've got both lights are solid green. It did stop the blinking LED. An MSO is an axis command, it's not a group command. You need to execute a motion axis shutdown reset to reset the axes first. Then you can turn it back on, which we just did. Although I executed an extra, well, here I only executed one. If you executed another, we went and selected that. Doesn't hurt anything. It shows two of them, both with no error. If something's already turned on, you can't turn it on again. But everything that you do is going to show up down here. Now let's do a jog. Let's set up to do a jog. We select an MAJ, motion axis jog, and of course all this pops up. Unfortunately, you can't stretch this box out, so you have to scroll up and down if you want to see everything. Most of what we see down here we don't care about anyway, not for this particular lab. You need to select an axis, but it's already selected. We're going to jog forward, and we're going to go. I had you put 360 in here in units per second. So that means 360 units per second. That's degrees. So that shaft is going to jog at 1 revolution per second. I have a fairly high accel and decel rates in here, and let's see what it's got. Oh, it's units per second squared, so that's not too bad. And we'll leave the rest of the same. Really, the only thing we did was put in a speed for the jog. And we left it default in the forward position. We're going to execute. Click on execute, and then I said in the manual, is the disc rotating in the positive direction? Yes, it is. I can see it is. Without stopping the motion, change the direction to reverse and re-execute. So let's change the direction to reverse first. Did anything change? No. Execute. Notice that the decel was very slow, and so is the accel. So it very slowly came to a stop, and then reverse direction, and very slowly went back up to speed. Change the direction to forward and re-execute, keeping your eyes on the disc. And of course it does the same thing. It slows down slowly and then slowly goes back to the forward speed. Just for grins, I didn't have you do it in the lab. Let's go to 500 for accel rate, and go to reverse and execute. It slows down real slow to a stop, and then very quickly goes back up to speed. So you can play with this while you're in here. I'll change that back to 100. We don't need a fast accel and decel. And of course it's already moving in the reverse direction, so I'm going to put it back in the forward direction and re-execute. Slows down very slowly, decel, stop, accel, and back up to speed. Leave the direction in forward and put a minus in front of 360. Go up here and we'll put a minus and execute. Slows down, stops, and ramps or accels back up in the opposite direction. Now notice we're going forward but with a minus speed. You could debate the pros and cons to that. I typically would go forward reverse and keep the speed as a positive number. By the way, you don't put a plus in front of that value if you want to go in a positive direction. Well, now you have it rolling. How do you stop it without hitting the panic button? Well, I'm going to remove that minus sign and re-execute it to get it going in the positive direction again. And just so I don't have to wait on the accel and the decel, I'm going to bump this up to 500 for both. So how do you get it stopped? Well, that brings us to another of the most simplest instructions. That is a motion axis stop. So we'll click on that. We've already got a axis selected. First thing you want to look at, stop type, all. Drop down the list. You can stop a jog, stop a move, stop a gearing, stop a home, stop a tune, stop a test, stop a time cam, position cam, master offset, move, and direct control. If you just want to stop it, leave it at all. If you had more than one motion instruction executing, then all would stop them all. But if you had something else going on and a jog, but you only want to stop the jog, then you would select jog. So we'll just leave it all. Change decel no. Let's try. In the lab I had you try picking a move. Okay? Had you execute it. Then I ask you the question. Look down here. See, we did a motion axis stop, no error, but because we selected a move, it didn't stop the jog. This time, we'll just pick all. I think you believe me by now. If I picked jog, it would stop it. So we pick all, and it stops it. Now, let's do that again. Let's do a jog again. It's jogging. And I go to back to motion axis stop. Watch the shaft. It stops right now, doesn't it? It doesn't decel, it just stops. Pretty sweet, eh? Now, this is really cool, and you can go through and do any kind of motion you want now with this axis from the motion direct commands. Let's do a home. While watching the motor shaft, execute a motion axis home. What does the motor shaft do? So let's do a motion axis home. Now watch the shaft. It's going real slow in the positive direction. It gets to the marker, it stops, and then backs up. The backing up motion is almost undetectable, but it does. It goes positive until it sees the marker pulse. Remember, there's one marker pulse on the encoder disk, so you get one marker pulse per revolution. Now I have my tie wrap adjusted so the little tab on it is pointing straight up when it's on the marker pulse. That's how I keep track of the home position on my shaft. Now, why did it behave as it did? And the hint, what type of homing motion did the lab instructions have you picked? Well, it had you pick marker. If you had picked switch or switch marker, it would still be rotating right now because it has to find the switch before it does anything else. Now, you could simulate that by wiring up, hardwiring to the drive itself a home switch or a signal to the input on the drive for the home switch. And then if you were to toggle that on, then it would find the marker. If you did switch marker, find the marker, and then back up, and that would be home. Okay, save your project and go offline. So I'm going to close this. I'm going to save. Whether you upload the tag values or not all the time is probably unnecessary. I want to be a good example, and the only reason not to do it is because you don't want to wipe out any offline tag values with the online tag values, or you just want to save time. So now we're saved. Let's go offline. You saved and you went offline. Now open the properties for the rotary axis and select the homing tab. Rotary, properties, homing. And we look at our sequence, we've got marker. And I did discuss these before. Immediate declares the current position home wherever the axis is at. Switch, it rotates until it sees the home switch made. Marker, it rotates until it sees the marker pulse. Switch marker, it rotates until it sees the home switch, then forward or reverse at a very slow speed until it sees the marker pulse. Now we already had markers selected. We'll just hit OK. I'm going to close this down so we can see the OK button. I did change my screen text size so the whole box would be in the viewing area. Now most applications use switch marker. However, some applications support a torque level marker where you home against a hard stop at a very low speed. That would be a situation where your actuator can run into a hard stop, and when it sees the torque spike or current spike, it declares that position as home. And it may actually back off a couple thousandths so it's more repeatable. Because keep in mind, when you go up against the hard step, there's a little bit of flex. and kind of a lash effect. And I've used that on many applications, the torque level marker. Here we're just using the marker pulse. Okay, save, download the project to the processor. I just went offline to show you that because you can't change that online. If you want to change your feedback setup, you know, your homing setup, you can't do that online. You have to go offline and do it. And since we didn't change anything, I'm just going to go online. I'm going to cheat and go online. You probably noticed while you were downloading that the controller goes into the program mode. That's just normal, no matter what the controller is. You may have also noticed, if you were looking at the drive, in this case it's a Circos drive, the Circos ring has to cycle through all the phases again, and when it gets to 4, you are all set to continue. Let's open the motion axis direct commands. Again, the drive is still enabled because we never stopped it. Try a home command again. So execute, and even though it was already homed and sitting on the marker pulse, it went forward and came all the way back around until it finds the marker pulse, then it backs off until the marker pulse just disappears. That's what the reverse direction is in the setup. Now, the motion axis home is a command that will take off running for home whether you have executed a motion servo on or not. So in MSO, you don't have to execute that. If I do motion servo off, see, execute with no error, I look over, the green light is flashing. Then if I do a motion axis home, it executes whether you turn it on or not. So that's something that you want to keep in mind. If you want to turn the drive on and do a home, the motion axis home instruction does both. Now, does the axis stay on when the home is complete? You can tell that if you go over and grab the shaft on the motor and try turning it. You can feel the armature or the torque in the motor fighting your fingers you try to turn it. I say careful, 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 because I don't know what you have your motor hooked to, and you go sticking your hand in there, I don't want you losing your fingers. If you have a motor that's sitting on a bench, you can grab the shaft with the end of your fingers. It would be difficult to hurt yourself even on purpose. However, if you have something else hooked to that motor, and the motor's actually bolted down and you grab a hold of it, it probably has enough torque to spin you around and upside down, and you're going to get injured. Okay, execute a motion servo off, and then try executing a motion axis jog, making sure to enter a speed. So let's do an MSF, execute, and then we'll do a motion axis jog. You got to put in a speed and execute. We'll drag this over a little bit so you can see the message. The command try to execute on an axis whose servo loop is not connected. Drag this out so you can see all the wording. Is not closed. The loop is not closed, so it won't execute. Did it execute? No. Execute a motion servo on and a jog, but put the speed at 0. Is it moving? If you grab the shaft and try to turn it, is it still in control? The disc or the shaft did not move. Gently try to rotate the shaft. Now in the manual I say disc. When I say disc, really that means the shaft. There are some people that attach a disc to the end of the shaft because that gives them more leverage for turning it by hand if they want to cause it to fault. I don't have a disc attached to the end of my motor, so shaft, disc, those words are interchangeable in the lab. Okay, the system is jogging at a speed of 0 right now. It is jogging, but it's at a speed of 0. Execute a motion axis stop. Motion axis stop. And then grab the shaft. Can you turn it? No, you can't. A motion axis stop and a motion axis off are not the same thing. If I do a motion axis off, then I can reach over and I can turn it by hand. It turns free now. We'll do home just to get it back in position. That's interesting. I did a home, but I moved the shaft in the counterclockwise direction just a couple of degrees and did the home. It only moved a couple of degrees, found the marker, and it was homed. I have a question there. And I said you don't have to fill in the blanks, but think or discuss it over before going on. If you do not understand the behavior you've seen thus far, browse through the manual, and I've got the manual document number in there, motion-RM002_-EN for English-P, regarding these motion state instructions. Your conclusions should mention that a motion axis stop is not the same as a servo off, and that you can jog at a 0 speed, and until you do a stop it's still jogging. So a motion servo on more than enable the servo drive. This instruction activates the servo loop. An MSF more than disabling the servo drive. This instruction deactivates the servo loop. The MASD, motion axis shutdown, it's not a group instruction. It's not the MG, it's just motion axis. Once the axis is shut down, the controller will block any instructions that initiate motion using that axis. And then of course an MASR, it's not a group instruction, but it's an axis instruction. This instruction moves an axis from an existing shutdown state to an axis ready state. It doesn't turn it on. If all of the axes are removed from a shutdown state, the OK relay in the drive module closes. It is possible to have multiple modules and not have all of them OK. I also mentioned that there are two instructions, the MDO and MDF, that are specifically for the analog motion module. It's the 1756 M02AE or PM02AE. And then of course there's an MDS, activates the drive control loops for the specified control and information protocol axes that you specify, and runs the motor at the specified speed. Well, if you have SIP motion, then you can use that instruction. And of course the motion axis fault reset clears any and all motion faults for just that axis. Okay, we've covered some of the real basic instructions, the on, the off, shutdowns, resets, stop, jog. Now let's do a motion axis move. Absolute moves on rotary axes. When an axis is configured for rotary operation, which is what we have, absolute moves are handled in the same way as with linear axes, except that when the axis position exceeds the unwind parameter, it is unwound. Kind of look at it as the threads on a bolt. If you have a inch bolt and so many threads per inch, let's say, I'm just going to make up a number, 16 threads per inch. Well, 16 rotations and the bolt's all the way in and locked down. It runs into a hard stop. So the longer the bolt with the same threads per inch, the more turns before it runs into the stop. That's the unwind, is you run the bolt all the way in, and when you run into the end of range, then you have to unwind it. And this way, axis position is never greater than the unwind value, nor ever less than 0. We were not even concerned about that, but because I'm assuming that you're going to do a project and use absolute moves instead of incremental moves, well, incremental really doesn't make any difference. There is no unwind because it's incremental. But with the absolute moves on a rotary axis, the specified position is interpreted trigonometrically and may be positive or negative, and may also be greater than the unwind value. In other words, let's say that you set your range to 7,200 degrees and you keep rotating in the positive direction and you get to 7,100. and then you tell it to go to 7,300. Well, you just exceeded that wind up, so it's going to unwind. Anyway, negative position values are equivalent to their corresponding positive values is the same as minus 90 is the same as plus 270, in other words, and are useful when rotating the axis through 0. When the position is greater than the unwind value, the axis moves through more than one revolution before stopping at the absolute position. Anyway, this is just a little note I threw in the manual in case you are working with rotary instead of linear. Most of the time it's linear. You have the motor hooked up to a linear actuator and you can't go past the limit because the actuator is going to hit the end of travel mechanically. Anyway, we select our rotary axes and then we select MAM, motion axis move, and of course it comes up to allow us to do absolute or incremental. We're going to pick incremental. It could be absolute, but we'll just pick incremental. And we're going to put in a position of 90. In other words, we're going to move incrementally 90 degrees at a speed of 720. That's 720 units per second, which would be 2 revolutions per second. It's not that fast. And then all the rest of the values we leave the same, and then we execute it. So watch your motor shaft, and it ramps up, and it moved 90 degrees. Now remember, I had the tab on my tie wrap pointing straight up. Now it's pointing out parallel with the horizon, which is 90 degrees. It moved to 90 degrees. If I execute that again, now it's pointing straight down. Again, now it's pointing in the opposite direction of where it started. If I execute it again, now it's back pointing straight up. So this is incremental. The position is 90 degrees incrementally from where it's at now. So every time you execute this, it's going to move 90 degrees in the positive direction. If I were to, just for grins, this is not in the lab, I'm going to change that and execute. Now it went 90 degrees in the opposite direction. Another 90, straight down. Another 90, another 90, back to the top. I'll take that negative out of there. Execute 90. Now it's going the positive direction again. Now I clicked on it 4 times in a row. So it saves all that up. So if I click 4 times very rapidly on execute, it's going to do 4 incremental 90 degree moves. What did this motor shaft do when you executed the motion axis move? Well, it moved 90 degrees, didn't it, in the positive direction. Click on execute again without changing anything. As long as the motion axis move is selected and has legal values, it will execute once for every click on the execute button. Try this. With one eye on the disk and the other on the MDC window, click execute approximately 10 times in rapid succession. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now all I see is the clock, the little swirly. But I'll tell you what, that shaft is going around to beat the band. And it did 900 degrees of motion. Now the reason I know it's 900 is because it's now pointing straight down. So I'm going to do 2 more so it's pointing straight up. Always remember, even though you're in the program mode and you've closed the motion direct command window, once you turn the dogs loose, there is no calling them back. If I say change this to 900 degrees and I execute, I'm going to execute this and then close the window. The window's closed, that shaft is going to beat the band now. Once the dogs are loose, the dogs are loose. There's no calling them back. You could do a motion, well from here you really can't do anything. You would have to go back into rotary, motion direct commands, and you would have to do a motion servo off or motion axis stop, or you could do a motion group shutdown to shut the whole thing down. In the manual I listed what I call the basic move commands. Motion axis stop stops the specified axis, motion axis home, jog, move, gearing, dynamic change, we're going to use that one in MRP, dynamic change of the commander position, Then there's a cam profile using an array of cam points. Then there's initiate camming between two axes. One follows the other. Initiate camming as a function of time. This executes a single axis to provide more complex profiles. So it's a time-based cam. And then, of course, calculate slave position, slope, and derivative of the slope for a cam profile and master value. That's the MCSV. We're not going to use all these instructions in the lab. We're just going to use the basics. In Lab 3, integrating motion with Logix, you're going to add some I/O modules. And I'm not going to make you watch the whole thing. Actually, what I'm going to do is I am going to leave the recording on, but if you don't want to see these modules added, then just grab the slider on your video player or fast forward some until you see that I'm finished adding the modules. Never hurts to see this again if you have not done this a lot. So we're going to close the motion correct commands. We're going to close the tag database, and we'll close the error window. We'll drag this open again. We're going to go down here and we're going to add some I/O modules. First thing we're going to add is an input card, and your input cards may be different. Remember, this is an L45. The L43 and the L45 have two buses, backplanes. There's a passive backplane that is to the left and an active backplane that's to the right. I did have somebody comment that the backplane is not passive, that a lot's going on. Well, it's called a passive backplane because the controller is not activating the modules on the backplane. They're set up, and when you boot up and go into the run mode, they get their instructions, and from then on, the backplane is passive as far as the controller is concerned. The backplane is always in reference to the controller, not the modules. Whereas the backplane to the right is an active backplane because the processor has to activate all the modules in order to pull data out or put data in. So I'm going to right click on the active backplane, the 1769 bus, not the 1768 bus. I'm going to add new module. You know, I think I'll go offline to do this. You see how slow this is when you're online? So I'm going to save. And when this is done saving, I'm going to go offline. I will meet you. So save, go offline. I show adding 1756 digital I/O modules because you might be doing this lab with a Control-Logix instead of Compact-Logix. And so there are a couple pages in there that show adding 1756 modules. We're going to skip those two pages, and I'm just going to add the 1769 I/O modules. So first we're going to do an input module. And the input module is an IQ16F. So IQ16F, double click, named DC input 02 underscore IN02. It's a DC input and it's in slot 2. So this is going to be slot 2. And I'm going to change this to disable keying so I don't have to fool with the rev level. Okay, that adds the input card. Go back to the bus, new module, uncheck check digital, and we're going to add an OB16P. OB16P. These just happen to be the modules that I have at the moment. That is in slot 1, of course. So it is DC underscore OUT01. DC output in slot 1. We'll change it to disable keying. Now in the real world you would want your keying set correctly. Let's collapse in this. Because I have a limited amount of space, I need to kind of collapse this to get this up where you have a good view. I can drag this window open wider, but then you wouldn't see it. Right click, new module. We did the DC in and out. Now let's add the analog, and we have a 1769 OF2 or an IF4. I don't have those two modules. I have the IF4X OF2. I have a combination module, but I left all of those in there just in case you have different modules. Check analog, and then we'll type in IF4, and we don't have the one that ends in F. We have the one that just ends in 2. Double click, and I'll call this analog in out slot 03. Disable the keying. because it's irrelevant for this lab. We do want to go to input configuration and enable at least channel 0 and 1, because we have potentiometers 0 to 10 volts hooked up to there. So then we go to output configuration. We're not going to use those, but we'll enable 2 anyway. Now, if you don't have I/O modules to work with, you can use the universal I/O that you created in an earlier project. That would have been back in volume 1. And for analog, you can create tags for each as double integers and label them as analog input 0 and analog out 0, etc. In other words, you just create some dents with the names analog in channel 1, analog in channel, and then you can manipulate the values in those registers and do the same thing that you would be doing by turning a potentiometer. You could also use a timer. Use, we'll say, hundredths of a second or tenths of a second. It's actually in thousands of a second, so you use values of 1, 10, 100, and so forth, and you can create a slope that looks like you changing the potentiometer at a certain rate. I showed you a rung in the manual that was 2 not equals in series and 2 push buttons. Well, they weren't, they're push buttons, so you can see the state. So this is just an example of a no-op rung. You can place in your logic and then select the field below the tag name and type in the desired value. For instance, you got analog in 0 and analog in 1. I'm talking about in the manual now. If you don't have the manual, then you don't know what I'm talking about. And you can type in right below source A the value that you want. You'll see that there are 2 push buttons there. Now remember, these are real push buttons connected to actual inputs, but these could be the universal I/O that I spoke of. And this is a convenient place for you to change the analog values and toggle the simulated inputs in a no operation rung. Remember, and I know you all know this, the logic works entirely with data in the controller's random access memory, and the logic, has no idea how the data got there or who put it there. It's just a tag. So the logic always executes from and to tags in memory. The logic has no idea where those values came from that it reads or where they go when they write them. It's all in the database. The next section of the lab, the first thing we did is I had you open the program tag database and add some tags. We're not going to go through that in the video. By now everyone's familiar with adding tags, and they could be controller tags or program tags, but I did specify program tags. I had you add a new subroutine to the main program named fault reset, and then add in the main routine an unconditional rung that JSRs to that new subroutine. And then I had you add this code into that routine. And you see some of the tags that I had you create here. This is a fault reset routine. If we get a rotary axis fault, then we use the MAFR to reset it. Input 0, this is in slot 2 of my hardware. Input data 0, bit 0, that we'll call that N0. That push button will reset the fault. If we have a fault, we want this light, output bit 0 or out 0, to turn on to display that there's a rotary axis fault. And then we also have a reset push button for rotary axis shutdown. And we use the MASR to reset that. If we have a shutdown, then we turn on this lamp, output 1, and then of course this resets the motion group shutdown. We'll call this our fault reset routine, and this is just to introduce you to the MAFR, the MASR, and the MGSR. Those are 3 separate resets. 2 of them are shutdown and 1 of them is fault. Then I had you add a new subroutine to the main program named Initialization. So you can see over here, I already have these added in. And so we'll open up Initialization. You added some more tags. Disable rotary's axis push button, enable rotary axes push button, home rotary axes push button, rotary axis enabled and rotary axis homed. The last two that I mentioned are outputs. The first three are inputs. You can see here's the two outputs, homed and enabled. And when I look over at the demo right now, actually I turned the drive off because of the background noise. But anyway, I had you add this code in. If we do home, this is an output. If the axis home status goes high, that turns on that light to show that it's in, the drive thinks it's homed. Then this is one-shotted, and if these conditions are good, then it enables the axes. And the enable axes then, if the group is synced. Now we only have one axis in the group, so this is almost irrelevant, but I threw this in because you typically see this, and this is a group bit from the motion group tag data type. We do an MSO, and we also turn on the light to show that the rotary axis is enabled. This push button we use to shut down, disable rotary axis. Basically, it's not really a shutdown, it's just turn it off. So that's our initialization routine. In the real world, this rung right here, rung 2, would be the interface logic and not a momentary push button. So I have a momentary push button here. This rung will suffice to control and indicate the axes enable status for our lab, but in the real world it would be more complex than that. So let's save and go online. So save, I have the viewing window stretched out. I'll drop it down a little bit. I went up here and clicked on save, and then we're going to go communications, who active, and we're going to download. And of course, I'm not going to make you watch this long drawn out download process, so I'm going to pause. Okay, you can see here's our main routine, and I have two JSRs. That is all that is in the main routine is the fault reset routine and the initialization. We'll go to fault reset first. I'm going to close this down. I'm going to geyser down so you can see the whole thing. In the lab, I had you fault the drive on purpose. I said you don't want to do this repeatedly, but with the axes enabled, force the shaft of the motor in either direction against the control exerted by the amplifier. If you have a large motor, this may not be possible. When you reach 90 degrees or so out of position, the drive will fault and release its influence over the motor armature. In other words, with the drive in control of the shaft and holding it in position, in other words, the drive is holding it at the encoder position that it's at. Force the shaft manually to rotate in either direction until it faults the drive. Right now, the drive knows where the shaft is at because of the encoder. You start turning the shaft, the encoder sends counts and says, hey, I'm not at that position anymore. So the drive tries to apply more torque, more power, to get it back to that position. And of course it can't because you're holding it away from that position, so it faults. So I'm going to do that now. Okay, the drive is now faulted. Okay, the drive is now faulted, and you see we have not just a fault, but we also have a shutdown. When I look at the drive, of course, the Sercos communication network is still good. My module status is flashing red, blinking red, and the display, which did show 4 before, is now flashing E22, E22. So when the drive faults or has an error, it will display an E and then followed by some numbers. You might just think that it's displaying E or displaying 2, but it's going E22, E22. If you go and look at what E22 is, in the manual I showed you both flashing red, minor fault, drive is faulted, but the fault could be cleared. Then I said to refer to the error codes. E22 is a motor thermal protection fault. It increased the power trying to bring it back into position, and it tripped the thermal sensor. In other words, it didn't actually overheat. but it saw that the temperature was going up because it was drawing a lot of current and the armature wasn't moving. And then it shows you the fixes. Well, in this case, I don't know how you would describe what I did other than I forced it out of position. You could reset the two conditions individually or together with input 2. Input 2 is a motion group shutdown reset that will reset everything. Or you could reset the axis fault with input 0 and the shutdown fault with 1. So I'm going to first reset the axis fault, and then I'm going to reset the rotary axis shutdown. Okay, we're back in business. The light is flashing green now, so we would have to do an initialization. We'll do a home first. That would be with input 5. The screen's a little slow to show, but I did push down that button. I'll do it again. See, in process, complete. And then we can do and enable rotary axis with 4. And now the light is solid green again. Next we're going to create a jog routine, but I think we'll pause and start a new section. Okay, let's take a little pause for the cause. This concludes part 2. Take a break, grab a snack, glass of water, a cola, go pet the dog, chase the cat. Whatever you need to do, take a break and look for part 3.